Does the force I apply to lift an object always do positive work? Well, if I'm thinking about an object, and maybe I'm going to redraw it over here. I mean, I think I have there in the slide a picture of an object that I might be lifting. I've got a free body diagram for it, and I'm going to claim that that free body diagram is relevant to all cases of lifting that I'm going to consider. In other words, I'm only going to consider situations where I'm lifting maybe relatively slowly, or at least in a way that the acceleration is approximately equal to zero. That's an approximation that physicists are willing to make for a situation like this. And that means that if I lift the object up, and if that therefore is the displacement vector, but for all of these, the applied force vector corresponds to the lift force that's in this free body diagram here. So I'm going to simplify things a little bit more and look at this as the first case and say, hey, what if I lift it up? And I think that leads to positive work. I'm just going to put a plus here, maybe in quotes, for positive work, because if I took that force times the displacement, I would get a positive number, right? That makes sense, right? Like we saw in the last example, I think. But is that the only way I could lift an object? Could I also maybe lift an object down? That might sound silly in natural language. I'm not sure if that's like, if somebody says, I'm going to lift something, usually we might assume that they're lifting an object up. But, you know, if you're taking an object that maybe is really heavy or something and you're slowly setting it down so that it doesn't get damaged, that would mean its displacement would be down. But as you're doing that, you would apply a lifting force. You still have to keep it, in a sense, lifted above the ground as you're slowly placing it down. So in this question, I'm interpreting it a little more loosely, what I mean by lift. I can lift things up, I can lift things down. And when I'm lifting something down, force and displacement are in opposite directions. And I'm going to claim that maybe it makes sense that this would represent negative work. Maybe another perspective on this is if I use the formula instead of just force times displacement, if I used FD cosine theta, what is theta for this situation? Well, one vector points up, the other one points down. They have 180 degrees between them. That means theta is equal to 180 degrees, and cosine of 180 degrees is equal to -1, which aligns with the idea that this should be negative work. Are these two the only possibilities that can happen? I would say no. There's one more possibility that can happen. What if instead of lifting it up or down, I'm just like, lifting it in a steady way, like I'm just holding it? Or maybe, either it could be at rest in that sense, but, what if I'm lifting it but like walking across the room, right? In that sense, there could be maybe a horizontal displacement. Maybe I'll have it displaced to the left here and say, okay, we're talking now about a displacement that's to the left. Lifting force still needs to be supplied to prevent it from going crashing into the floor, because that's what gravity would do if I stopped providing that lifting force. But in this case, what would happen is work would be equal to 0. There'd be no work done at all. And from an FD cosine theta perspective, I would say theta is probably 90 degrees here, and cosine of 90 is equal to 0. So that formula actually gives the correct answer. But these are maybe three situations I'd like us all to understand in general conceptually, is that work can be positive, it can be negative, and if a force and a displacement are at right angles, work is in fact 0, and these things are going to come up. So let's check out the answer here with this picture. It says if the object is displaced upward, the lift force is in the same direction as the displacement and does positive work. And there it is, it went up. And we say that's positive work. If the object is displaced downward, lifted down, right? But the lift force still supports the object upward, so the work done is negative. There it is. But the other possibility was if the object is displaced horizontally, the lift force that supports the object does not do any work. Moreover, the work done is 0. And I said down here the work done is 0, and here I said no work. Those really mean the same thing to a physicist. I always want to repeat that because sometimes people come out of a math class and saying, there's a big difference between saying the solution is 0 versus saying there's no solution. And in math, that's true. But if a physicist says work done is 0 or says no work is done, it means the same thing.